So this talk is called, it's got a long title, so you'll have to excuse me. The biggest trick consultants ever pulled was convincing the world that continuous delivery was easy. There is some serious ranting, okay? There is some serious trolling in this talk. If you're a continuous delivery consultant, I apologize. I don't mean to pick offense with you. We'll talk about why as we go through the talk, but this is a fun talk in order to understand about delivering systems. Okay, it's not meant to be, you know, very serious or anything like that. My name's Paul Stack. I'm an engineer at a company called HashiCorp. This is not an official company talk by any stretch of the imagination. Please don't take it that way. Please don't think that this is what my company advertises. They do not. I'm a DevOps extremist. I absolutely buy into the idea and the concepts and the systems around DevOps and understanding exactly why they're there, not just making it a buzzword. And lastly, I'm a traveling junkie. I think this is conference number 14 of the year. I have 3 more before Christmas. So I love talking about this. This is like my real passion. This is my real understanding about why I deliver systems. So my background to this talk, I joined a company in, wow, it's like 12 years ago right now. That makes me feel really old. I know I look very youthful. I joined a company 12 years ago, and it was one of my first jobs. And when I went to work on the first product, my boss actually told me, he says, "You're going to work on this product." And I was like, okay. And he said, what you got to do is you got to remote desktop into this machine underneath my desk. You got to, you got to work on the source code on that machine. It wasn't in source control. It wasn't able to be built. And he said, when you're finished it, you take the raw C# files and you put them straight on the server and they compile on the fly. Okay. So even as like a very green person in the industry, somebody who had no idea what was going on, I was exposed to extremely bad practices from day one. And this happens all the time. Okay. And I'm not saying that if you're doing that, you're wrong. You are. But that's a different problem. It's more a chance for understanding that if you are doing that, then you're making your life more difficult in software delivery. Much more difficult. And this is what the idea of continuous integration and continuous delivery has been brought around to do. And it's not a very new thing. It's been around for a long time. Anyone follow continuous delivery? Anyone continuously deliver? A few people, okay. So just a recap, okay. Continuous delivery is practices and principles aimed at building, testing, and releasing software faster and more frequently, okay. Now, there's a key word in there. There is a key word in there, and it's releasing, okay. Who likes releasing their software to production? Literally, like 5% of the room, okay. It's when bugs start, right? So what we do is we write all this code, and we're like, actually, you know what? We're going to refactor it a little bit more. And we're going to add this feature. Oh, actually, the business people, they want one more feature. And we like defer and defer and defer and defer our releases all the time. And then what happens is we go, oh, crap, we actually really have to put this, piece of software in production and let people use it. And then we find that there's bugs in it. Always, like, take it from me right now. You write software, you're actually delivering bugs all the time. Not a single one of us writes bug-free code. I'm awesome, but I still don't. It's really important, and as we go through, we'll talk about why releasing is important. There are principles, okay, I'm not going to read these out. This is all very well documented, like really well documented. But there are 4 key practices, okay. Firstly, build your binaries once. Please, for the love of God, do not rebuild your binaries between environments. I don't think you understand how risk adverse it is when you keep the same binaries all the time. Number 2, Use the same mechanism to deploy to all your environments. Don't use Docker on your local machine and then not use Docker on your production machine. I'm not advocating using a tool. Don't use Docker, ever. I'm kidding, I'm joking. But if you don't have the same mechanism that delivers all the time, it's very difficult to make sure that your mechanism is flawless. Very, very, very difficult. The company I worked for that I started talking about, the talk, they didn't have a dev system. They didn't have a staging system. They literally took the raw files and put them in production. Okay? Number 3, smoke test your deployments. I'm telling you obvious stuff here, right? And you're sitting here thinking, yeah, this is easy. You would be surprised at how many people do not test their system when they've released it. And as a software engineer, the most embarrassing thing is when somebody, an end user, comes and tells you there's a bug and you don't find that bug first. It's extremely embarrassing. And number 4, if anything fails, stop. Don't keep delivering crappy bugs in the production. If you find a bug, fix it. It's really good. Anyone ever read the book? Continuous Delivery? Okay. It is a really big book. It's a massive book, okay? This book was the seminal book on continuous delivery. It was written in 2010, July 2000. It was published, in July 2010. It was written quite throughout years before that, and it's written by Jez Humble and Dave Farley. Okay, so am I saying that continuous delivery is only 6 years old? No. We're going to talk about the Agile Manifesto really briefly. First point of the Agile Manifesto actually mentions continuous delivery. It really does mention it. This was written in 2001. Okay, for those who don't know about the Agile Manifesto, it was like when a group of extremely, influential people in IT got together and decided to create good principles and good practices of software delivery. Okay, and in 2001, I wasn't even in IT. Okay, so the fact that back then, 15 years ago, they're still talking about delivering software and continuously delivering software is amazing. But there are some fallacies. This is where I'm going to rant. Okay, so please just bear with me. This grows all the time. I added a new one yesterday. Okay, and it does, I hear so many common misconceptions about what continuous delivery is. Number 1, continuous delivery is only something that startups can achieve. Rubbish. Absolute and utter rubbish. Who works for a startup? 4 hands. Who works for an enterprise company? Most of the rest of the room. Exactly the point. Just because you work in a startup doesn't mean that you're doing the best stuff all the time. In fact, I know many startups who are doing a lot of very bad practices because they're about delivering things very quickly to users in order to test how things work. If you work for an enterprise, you can do continuous delivery. You can aim towards the journey of continuous delivery. It's not a problem. It's about taking small steps in order to deliver your systems better. Number 2, continuous delivery only works for Node.js, Ruby, or Go developers. Hands up, Go developers, Node.js developers, or Ruby developers. Very few of us. Very, very, very few of us. You can continuously deliver in any language. Is a language. It doesn't matter. It's syntax. Okay. I'm actually hearing more about continuous delivering for embedded systems. I'm hearing more about continuously delivering for mainframe systems. The industry is changing in order to focus on delivering our systems these days. One of my favorites. We can hire a consultant to help us implement continuous delivery. Now, I'm very sorry to anyone in here who is a consultant and actually sells continuous delivery solutions, but you really cannot. Please do not inflict that on this industry anymore. This is a very bad practice because you cannot help a company move towards continuous delivery without understanding about the company's ecosystem, without understanding the relationships and the business problem and the domain. You can go in and help a company write some scripts in order to help them build things and deliver things, but you are only helping them write some scripts. That's it. If you want to help, you cannot, in my opinion, you cannot help a company down this journey without really being part of the company and really buying into what the company does. Because otherwise, you're just automating some crap that when you leave, somebody else has to maintain. Number 4. Continuous delivery is not right-clicking and deploying in your IDE. You joke. You joke. Up until January this year, Microsoft Azure had a button called continuous deployment built into it in the first portal. Okay, because it's enterprise, right? That's what people want to do. Number 5, we're not going to dwell too much on that one at all. Continuous delivery is not hooking Azure or Heroku or AWS to your GitHub account. I do it from my blog. My blog is down most of the time. If you're delivering your production system this way, you'll probably be down most of the time. People do this just to annoy me. Dominic Bayer actually tweeted me and told me, he says, I just deployed from GitHub to Azure just to annoy me. Okay, because they know that I'm really passionate about this. Number 6, containers. It's not a silver bullet. Let's not dwell on that because I will go on a side rant completely. Number 7, DevOps means that we don't need ops teams. Wow. Just because there's a new word in the industry means that we can destroy an entire part of what we do. Next, you'll be telling me that serverless means that we don't even need development teams. We're just going to think some code and that's going to run in production. What we're going to do here is we're going to give everyone SSH access to production or RDP access to production. Do you think that's going to end well? No. No. As people, when we RDP or SSH into machines, we tinker. We change things and we look at parts of the file system that maybe we shouldn't. You know, we cat log files, we look at PID files, we maybe start and stop services. Do we know the ramifications of what we're going to do? Nope. 8. Using Chef or Puppet or Ansible means I'm doing DevOps. A tool doesn't mean anything. A tool is a tool. Okay? In the same way as if you're writing Go, doesn't mean that you're greenfield and you're doing continuous delivery. Means nothing. Absolutely nothing. Number 9. We can hire a DevOps team to create the Jenkins jobs and bash scripts for our deployments. Hands up, anyone who has a DevOps team? Hands up who's had a DevOps team past 3 or 4 years ago, is older than 3 or 4 years. And did you call them DevOps 4 years ago?
Yes.
Really?
We were ahead of the curve and we still
Love that. Love that. Okay. Let me ask you a question. Would you hire an Agile or a Kanban?
Would I hire an Agile?
Yeah.
I don't even know what that means.
Exactly. Exactly that. Exactly that. DevOps is a terminology, okay? It's not a specific, in my opinion, it's not a specific role, it's not anything else. It's a communication, it's a concept for communication between systems and between people and understanding and how delivering the best software you can, okay? In the same way that Agile is a development methodology and Kanban is a development methodology and a flow methodology. It's an understanding and a thought process. Number 10. I'm going to rub a little DevOps on that and make it better. That was actually posted during a keynote conference last year by one of the presenters on stage. His job title is just the most ridiculous job title I've ever heard in my life, and I'm not going to tell you what it is because it's not my place to say it. What does that even mean? What can you rub DevOps on? All right, and one that I found yesterday, and it's not in the slides, and I will publish it as part of the slides. The new Visual Studio 2017 has a right-click button that says Configure Continuous Delivery. Really, like, honestly. So, there are so many fallacies in what we do. There are so many different ways in which we can do things, and there are so many different ways in which we can break systems and mess up. Mary Poppendieck, who is just one of the most inspirational people I've ever read about, read her work and her thoughts on development methodologies, actually asks the question, how long would it take your organization to deploy a change that involved a single line of code? And can you do it on a reliable, repeatable basis? If I were to ask someone, does somebody want to tell me, give me an example of what would happen in your organization?
You push the code, you go to the orchestration system, you decide you want to release it, and then it's production.
So it's 10 minutes. 10 minutes for you. Ish.
Depending on the service, depending on a bunch of stuff.
Okay.
That's the ballpark.
Anyone has any better or worse than that? Man at the back. 4 seconds. Wow. 4 seconds. Anybody has any differences in 4 seconds?
Yeah, but deployed a UAT, sits around a UAT for about 6 months, comes back over and over again, and maybe by the end of the year.
Maybe by the end of the year. Wow. Okay, so the general consensus on this, okay, and it's strange that no one has said this in here, is usually it depends. If it's a bug fix, I can get that to production in maybe an hour. Okay, but for general software development features, 2 weeks, 3 weeks, 4 weeks, whatever. Okay, let me ask you a question. Why do bug fixes differ in our release process than normal features? And in that state of panic, does that mean that you could potentially introduce more chaos into the system?
Potentially, if by potentially you mean generally, even sure.
We can measure this, okay? This is a measurable thing. Okay, this is called cycle time. And you can measure it and you can draw it. And this is a value stream map which shows the cycle time and shows you how to do this. Okay, this is for a company I used to work in the UK, and this was before we had a major change to how we did things. We used to deliver our systems every 6 weeks. Okay, 6 weeks doesn't sound too bad. It was about 1.6 million lines of C# code in a single monolithic repo, and we used to have what was called merge weeks. So we would have 4 weeks of feature development. Every team would have their own branch on SVN. And we took literally 1 week for 5 teams to merge their code back. An email chain used to start on a Monday morning saying, we're entering merge week. And there would be an order of which teams would get to merge their code first. And the person, obviously, who merged their code first, no problem, merges easily. The person who merges their code last, yeah, you're going to have a sucky week. I can guarantee you that. I've been involved in many of those, and it was terrible. And then we would have had 10 days of testing. So the CTO came to me. He was like, Paul, how can we make this better? He says, you're the guy who loves continuous delivery and continuous integration. Tell me how we can make it better. I was like, do we understand the problem? He was like, well, we're taking 6 weeks to deliver our software. It's like, so let's plot it, let's draw it, let's measure it. And we measured it as follows. So an issue was reported, or something happened in our system, or a business person came to us and they entered a topic. Okay. That sort of took a little bit of time. They took maybe 15, 20 minutes to open that issue, to have a good discussion about it. It then sat in a queue for 3.5 days. We prioritized it in our weekly prioritization meetings. And then it sat for 4 more days. Developer actually took 2 hours to fix the code or add the feature. But then, you know, in the nature of what we do, we didn't want to get that in the release to production. It waited another 4 days. The QA tested it, very fast test, and it waited another 4 days, and so on and so forth. When I pointed the CTO to this, he looked at me and he said, why do we wait 19 and a half days of doing nothing in the system? This is called waste. Okay, I'm not telling you that I'm not here to tell you that if you're wasting time in your system that you're not delivering the best software you can. Or I'm not here telling you that you must do lean or Kanban in order to deliver your systems. What I'm trying to tell you right now is that if you measure the time taken through all the different stages in your system, you will be able to help make that system more fast running. That process will become better. When we measure things, we understand where the limitations are and we can always make it better. A guy called Chris Reed, at a London meetup in 2011, I actually used a very amazing quote, and I use it everywhere now. He said, until your pretty code is in production, making money, or doing whatever it does, you've just wasted your time. According to Chris's blog, Chris says that his job is to help developers and operations people deliver code deliver more value faster. And this is very poignant for me because I used to be one of those people who was always very afraid of delivering my systems to production. But then I realized to improve, we need to measure. We are going to make mistakes, but we can get better at what we do by measuring those mistakes and understanding what those mistakes are. It's not all doom and gloom. The rise of DevOps is a very big thing right now. Very big thing. Anybody actually, apart from Chris, anyone actually know the history behind DevOps? Anyone know where the idea came from DevOps apart from you? It was at a conference. I'm liking this. I'm liking this. Okay. So in 2009, the wrong conference. Oh, no. I know. In 2009, you had a conference in San Jose called O'Reilly. Now, I'm probably going to be told I'm wrong right now because one of the people who was behind DevOps is actually sitting in the room. And if I get this wrong, it's going to be slightly embarrassing. In 2009, there was a conference in the States, okay, called Velocity Conference. And there was a talk at it called 10 Deploys Per Day, Dev and Ops Cooperation at Flickr. Okay, there was 2 people who gave that talk, Paul Hammond and John Allspaw. They have since become extremely well-known people in our industry, and it was a very phenomenal talk because of the fact that of 2 things. One, in 2009, I can't even imagine doing 10 deploys a day of my software. I was still writing the worst code that you could ever read. But secondly, you had a developer and an operations person on the stage at the same time. Traditionally, in our companies, the operations people live under the stairs, and we give them the odd pizza every so often to keep them happy. But these 2 people came together on the stage in order to talk about how they work together in order to do better things. And discussions happened all over Twitter, and 2 people who were very, very vocal on Twitter. One was Patrick Dubois, the other one was Paul Nazrat, and Patrick suggested that maybe we should bring a Velocity to Europe at that point, and it continued on. But they decided on a different way of doing it. Okay, so on October 30th and 31st in 2009 in Belgium, I'm not going to pronounce the name because I was in Belgium and got told off by my pronunciation of the city. I was told, somebody told me it was Gent. Okay, he was Dutch. And it was a conference for developers and system administrators for 2 days. This is crazy. Is it dev and ops people for days, and it became known as the DevOps days. Now, people came from literally all over the world. So one of the guys who came was Lindsay Holmwood, and he actually came from Sydney the whole way to Belgium in order to be part of this conference, because this was like a real way of sharing the information. A lot of people were tweeting about it and hashtagging DevOps days. And of course, space is limited on Twitter, so they dropped the days and they hashtag DevOps. Now, I believe that is actually where this came from. This wasn't sat around in a huge building like Trump Towers with 15 executives around a table saying, what is the new craze in IT? Let's call it DevOps. This was a movement by practitioners for practitioners. This was a way of people sharing their pain, their anguish, and the best practices on how they were able to deliver their systems. And what was discussed at this conference was that there was this wall of confusion. Okay, you have developers on one side and you have the operations people on the other side. Developers wanted to change systems, they wanted to introduce new technologies, and operations people were like, no, that's not happening. I've been in a company like this. I worked in a company that used to pay their operations team for uptime. They used to get bonuses based on the fact of if they had 100% uptime at the end of the month, they would get extra money in their salary. But because they did that, the software engineers were never allowed to release their software. I take that back. They had a maintenance window. And the maintenance window didn't count in the downtime. And the maintenance window was 3 hours a month. Okay, so 3 hours, the system was down, but it was a planned down. Right? And if you're confused about what the actual terminology behind dev and ops, DevOps Borat says it really well. He says, if you're praised for website success, you're a dev, and if you're blamed when the website goes down, you're ops. And what generally happens is, as a software developer, you take some crappy code and you throw it across a wall to an operations person, and the operations person deploys it. I have a USB stick here. Anyone want to take that and put it in their laptop? You're afraid to. Perfect response. If you're afraid to take this and put it in your laptop, why should I deploy your code that I have had no part in writing? Because I'm afraid to do that, right? And we get into the situation of, it worked fine in dev, it's your problem right now. This happens more than we should actually decide. So what's DevOps? A great quote on it for me. DevOps is not about learning each other's jobs. It's understanding that money is made when your software is running in production. I had a conversation with someone before the talk, and he said, "Oh yeah, are you into DevOps?" And I was like, "Yes." And he was like, "Does that mean that I have to I have to understand operations as a developer?" It's like, no. It's about us working together to deliver the best system. It doesn't matter if you understand operations. It doesn't matter if I understand code. It's about us communicating in order to understand that we both know what is being delivered. And DevOps, there are 3 ways behind it. This is all well known. This is all in the public domain. Gene Kim talks about this an awful lot, and he says there are 3 principles that underpin it. Okay, number 1, systems thinking. Number 2, we amplify feedback loops, and number 3, we create a culture of continual experimentation and learning. First way, systems thinking. It's the flow of information from left to right. I'm not going to dwell on these points at all. Okay, think of it in terms of the flow of features from the business to the customer. The second way, if we have a flow of information from left to right, wouldn't it be great if we also had a flow of information from right to left? Because in most organizations, we do left to right, and we do that really well. Let me give you an example. That code you delivered yesterday to production made the CPU more intense by 15%. Could you, the next time you're in that code area, look at that? That is really useful information as a developer. Instead of going, what usually happens in organizations these days, that code you wrote yesterday was crap, you need to fix it. Okay? The understanding of information between, the flow of information from people actually needs to have a lot of context. And usually because of the walls that we create in our organization, we don't flow that information between departments very well. Hands up whose operations team sits beside them as developers. Now it's poignant that your operations team sits beside you as developers, and yet you told me you deliver your code really fast. So it works hand in hand, right? Whereas the people whose operations teams work in a different building, sometimes even in a different city, it's really difficult for code to be released as an organization in that way. Patrick Lightbody of Browser Mob actually tweeted quite a few years ago. He said that when we woke developers up at 2 a.m., defects got fixed faster. I am newly married, and the one thing that my new wife hates is when my pager goes. I can pretty much guarantee you that if my pager goes at 2 a.m. or 3 a.m., the next day I will be fixing some code, because I do not want an angry wife. We shouldn't have to deal with this. I follow the principle of if you write it, you run it. You should understand how it runs, and you should understand your environment in which you have to run it. The third way, if you have a flow of information from left to right and right to left, then you can start to experiment. Anyone do multivariate testing on their website? Okay. Oh, interesting. So, multivariate testing is a great example. Facebook. I've had the privilege of going to their office and understanding their development technologies and how things work. I am told by some of their engineering team that they released the first feature of their website to 17% of the female population of New Zealand. And they have enough people using it in that category that they can get very fast feedback about their features. It's the first time zone of the world, so they can understand when people use it before the major metropolitans across the world come online. Netflix do this as well. Netflix released their systems in Europe faster than they do in the US, because their user base in Europe is much smaller than it is in the US. Booking.com are a fantastic example of it. They have written they've given many talks about this, and they have an amazing system where almost every user will go on and see something very slightly different in their system. Now, when I mean something different, it could be as simple as the button that says reserve is 1 pixel to the left and has square corners rather than rounded corners. That's multivariate testing, being able to test these different approaches to see how it reflects what you do. This is a really well-known way of understanding how small changes in your system can reflect amazing things. One of the people I used to work with, we used to have this thing called 30% time. Okay, we used to have like just over a day every sprint, and it would allow you to like test out a new feature on the website. One of the developers I used to work with actually tested a very small feature, and it actually gained the company just over $100 a day. It took 2 hours for him to write this feature, and it was $100 a day. Okay, without understanding this experimentation, without putting the processes in place that allowed us to release and measure what we're doing, he would never have been able to do that. Well, he probably would have put it into production, but he wouldn't have been able to understand the impact on the company. When we increase experimentation and learning, we see two things, okay? We will fail often. We will, because not every feature we put into production is a good feature. And secondly, we will inject faults into the system. When we have all of these things in place and we experiment and we learn and we understand what's happening in our system, we will find that there are more bugs in our system. And we can fix them faster and we can deliver faster. This is the idea behind flow. Okay, there are 2 books that help you understand flow. The one on the left is called The Goal. I believe it was written in the 80s, something maybe even earlier. Okay, and it's written by Ilya Goldratt. And it's incredible. I read this book, I reread it regularly. Okay, I'm like one of these quintessential software geeks who like loves delivering systems. And when I read this book, it was nothing to do with IT. Absolutely nothing to do with IT. It was all focused on a manufacturing plant in America. And it was all about understanding how the different parts of the plant work together in order to understand how they could ship products as a company. And of course, that is can be very much related back to IT, because as a company, we have to work together in order to deliver our systems. And it was rewritten. There was a re-implementation about it in 2012 by Gene Kim, Kevin Baer, and George Spafford, called The Phoenix Project. The Phoenix Project is an extremely well-known book now. It's a novel about an IT company. And I gave this to people I used to work with. And I quote one of the engineers I used to work with. He said, "This book almost was my life before we started changing towards a continuous delivery methodology." He said it was almost as though the authors had followed him around the building and realized how bad everything was in the company. It helped me understand a major thing. We're all part of the same team. Not like us. We're all in different companies. But within a company, you don't have to compete against other people. You should work together in order to deliver the best system for your company. You must aim towards be as professional as you can and deliver the best system you can. A high-performing team is a team that works together. Only when we work together, we'll be successful in what we're trying to do. If you go to work every day and you want to write the fastest code, or you want to deliver the best code, or you want to release your systems really quick, you're putting yourself into an area where maybe you're going to compete against other people. If you're competing against other people, then sometimes there are conflicts within the team. Conflict is not bad, but we're all part of the same team. We must remember that. 2014, John Turner of paddypower.com in Ireland was at a London CD meetup. And he presented this graphic. And the graphic is really great because he said members of his team understand all pieces of what we're doing, and they graphed it. And he was, and when everyone was like, "What do you mean by all pieces?" He said, "Well, members of the team understand that in order to release software, we need unit testing, we need log aggregation, we need application blueprints, we need infrastructure APIs." And he color coded them. He was in London, so he like drew it in the shape of a London tube map, which was great. But it worked out really well because what he was very clear on saying was that just because you're a QA doesn't mean you have to stick to the gray. You can be involved in the green. Just because you're a software developer doesn't mean that you have to stick to blue and gray. You can actually be involved in the networking side and in the infrastructure side. Because by the understanding of how your system runs in production, that is actually when you deliver the best systems. The talk actually demonstrated that to need value, to deliver value for your customers, it was the communication between all of these pieces working together in order to deliver the code. And there are ways to do it. Configuration management. Who uses a config management tool? Puppet, Chef, Ansible. Insert other name here. Oh, don't worry, I'll get to those. Don't you worry. for those who don't know, a configuration management tool, it allows us to define the state of a machine or an infrastructure, and the config management tool will keep it at that state. It's a very declarative way of doing it. So for example, you would say something around the region of, I need this Linux machine to come up, I want Nginx to be installed, I need these 5 users on it, and a config management tool would do that for you. Okay. There's another way of doing it. Rather than changing the machines on the fly all the time, there's one called immutable infrastructure. Okay. Chad Fowler from a company in Germany called Six Wunderkindle talked in 2013 about how immutability differs from configuration management. They don't change their servers when they're in production. What they do is when they need to change them, they throw them away, start again. And this works really well in the cloud, and sometimes it doesn't work very well like in old data centers and different ways. So this is not replacing configuration management. This is just another alternative way of doing it. Any functional programmers in the room? Yeah, functional programmers were like, that's not really immutable because the state of the machine changes quite often. Logs are written, people log in, etc. So a guy called Mark Burgess last year, who is incredible. He's actually he created CF Engine, which is like the godfather of all configuration management tools. He said maybe disposable infrastructure is a better way of doing it. Okay, because when you call something disposable, you immediately have the idea that it does have a lifespan. It can be thrown away. Anybody work in a company that actually deprecates software? Very few of us. We sometimes hang on to crazy pieces of software. Internet Explorer. Logging. You can't understand how your systems work and how they work together without logging. I gave a talk, 2 days ago now, about centralized logging and about how they build really easy systems. The amount of people who don't have centralized logging systems right now is madness. Absolute and utter madness. Because you have no idea what's happening in production. None. And with logging, you can do all sorts of crazy things. This was a graph from the company. It's really funny Maria knows it because she still looks at this system many days, every day. And this was like taken... I have permission to use this, don't worry. And what it said is that we were able to get this key information because the APIs were broken down into different tags, and we could see that 22 million requests came in, and out of those 22 million, 70 requests were non-200. We were given this information right to developers in their face that they could look at every day in order to understand how their system was working. We could understand that when a deployment was made, there are some tags on the graph right here. And we could see that when a deployment was made, requests were going up. We had a spike, but because we had a spike, our cache misses to Redis went up as well.
Are you making the distinction between logging and metrics?
I'm not. For me, log is information. Okay, metrics is information. Personally speaking, I have other talks about this type of stuff. For me, it doesn't matter. Right? This is just messages, okay? This is just not just logs. This was like, obviously, the non-200s create logs, but I can grab all of this information and I can make it really visible and they understand the information available for developers. This is talking more about the fact that when we have that flow of information from left to right, this is the information from right back to left. As somebody who runs systems, I want developers to have access to how their system is performing. Okay? But you can have metrics as well, of course. You can have time series data. Okay, so you can look at things like the CPU of your servers. But without understanding the idea of the context between those, it means nothing, right? Most people, when they put metrics together, they're like just having a metrics agent on each of their servers and it's reporting back, and that CPU is going up, the RAM is going up, the disk is going up, and they get paged. Do you know, usually, how quickly the RAM goes up? Is it a percentage change by second? Most people even just aggregate metrics every minute. So did it happen last minute? Did it happen 2 hours ago? Did it happen 5 days ago? So it's all about all of this information coming together in order to be the most effective information about how your system is running. I use Graphite, or excuse me, Grafana, right, as a metrics API, as a metrics dashboard, and it integrates with many systems. It allows me to like see 5 or 6 different systems all in one go. Monitoring. Monitoring is something as an industry we do very badly, extremely badly. Our monitoring is usually the web instance is down. The API has stopped. Our disk is full. It doesn't give you any concept of what is happening. It doesn't tell you that the disk has filled up over the last 2 hours because we've had a crazy spike in requests and we have a bug in our software. This has to, without just putting monitoring on its own and using Nagios, for example, is like zero. You need a lot more rich information around what you do. Orchestration. Anyone use an orchestration tool? So the two that I usually hear, people usually say, oh, I've used Jenkins. Jenkins is my orchestration tool. And other people use Rundeck. Okay, Rundeck is one of my favorite tools on the internet right now. It's just awesome. But you don't have to compete against them. Okay, an orchestration tool basically allows you to automate software tasks. Okay, builds are part of orchestration. Deploys are part of orchestration. Okay, also things like testing that your website is secure. Doing things like always run an SSL scan across your website. Making sure that your SSL certificates are still valid. All of these different things can all be orchestrated and work together. It's all about making reliable, repeatable, and secure things happen within your environment. Data center as code. Anyone ever heard of a tool called Terraform? Okay. This is not a sales pitch. I work on that code. I work on that product. And the idea behind the product is that you can actually define your entire system in code. So your load balancers, your DNS, your users in Postgres or MySQL, that can all be defined in Terraform. And that can all work together and orchestrate how your system is delivered. The nice thing about moving towards a data center as code model means that you don't really need a disaster recovery plan. Your disaster recovery plan is changing a variable at the top of your file and rerunning your infrastructure in another region. Somebody asked me, I worked at a small startup, and they said, what's our disaster recovery plan? And I was like, well, it's this. He goes, yeah, but I need a disaster recovery document in order to show our investors. So I printed my Terraform scripts and said, there you go. I actually did, I'm not even kidding. And he was like, what is this? What even is this? And I was like, you asked for a disaster recovery document. I've given you a disaster recovery document. And he was like, so we can like change our entire environment? And we were running in Ireland, EU West 1 in Amazon. And I was like, yeah, if you want to, let's try it. And we were actually able to fail over from one region to another in less than 6 minutes. It actually took almost 6 minutes because RDS took 6 minutes to spin a database up. So if there was the problem with disaster, and Ireland was, God bless it, if Ireland was blown off the face of the earth, then I could actually spin up my entire environment in less than 6 minutes, and I would have had maybe 6 minutes of downtime. We're moving in the same way for networking. Software-defined networks is now a thing. A study is done every year on the benefits of continuous delivery and DevOps. And it's usually coordinated by Puppet Labs and a few other vendors. Okay, and this is the results of the 2014 survey. It shows how long I've been talking about this. I should really update this slide. But I'm like reiterating the same crappy talk for a long time. But what it says is that high-performing IT teams are more agile. They can apparently deliver code up to 30 times faster with 50% less failures. 30 times faster. And 50% less bugs. Apparently the lead time for changes in their system can be as much as 8,000 times faster. I don't even want to know the people that they interview to understand the difference between 8,000 times faster. That just seems ridiculous to me. High-performing IT teams can recover faster. This I 100% agree with. Recoveries can happen apparently up to 12 times faster. Netflix are a great example of this. Netflix used to run their software on US East 1 in Amazon. For those who know Amazon, they will know that US East 1 is the oldest of the Amazon data centers and is the one that goes down the most. It is also the default region when you sign into Amazon and most people launch their software there. So when there's a problem in US East 1, a lot of people suffer. And what they were able to do is they realized that there was a problem in US East 1 and they were actually able to completely fail their entire operation to US West 2 within minutes. Most other companies are like, oh my God, our system's down, what's going on? Netflix are like, YOLO. They're like just continuing on and like everyone's still watching TV shows. High-performing IT teams can experiment more. If you can deliver code faster and it's less buggy, you can really start to have some fun in production. You can try little things all the time. I'm told from this survey that people are actually spent 37% less time firefighting. When you're part of your sprint planning every week, do you plan for bugs in production? What's the point? But it happens. So do you portion part of your time for understanding how, I have to debug this code in production?
That's the point. Like you don't know if you need a minute, an hour, or like a month.
Right.
Depending on the bug.
Exactly. But it happens, and what it does is it stops us from creating software during that time. Because if you're spending a month debugging something, that means it's a month less of features released, right? Do you include time for deployments in your sprint? But yet it happens every sprint. So why don't you apportion some time for that to happen?
We portion time to build a system that allows us to deploy almost transparently. So
Almost transparently. Almost. Right. What I'm trying to suggest here is that we do the same things all the time. We write code, we test code, we release code. Bugs happen. When bugs happen, we panic. We have no idea what's going on and everything stops what we're doing. When that's actually the case, we've already made an agreement with our product manager that we're going to release these 4 features this sprint. But we don't know if we're going to release those 4 features this sprint because we don't know what's going to happen. So right now it's all about understanding your environment and understanding how things work together and understanding that in order to be a high-performing IT team, you do need to focus on understanding how your system runs in production. Because if you don't, you have no idea. Absolutely zero idea. Continuous delivery means better products for our customers. It's really important that when I say customer, it doesn't just mean an external user. As an operations person, I create tools for the engineers in the company. They're my customers. Don't make them use things like SharePoint. You can adapt your changes and your feature requests a lot better internally when you work together as a team. I have 42 seconds left. Does anybody have any questions? Oh. How do you make sure that your end user is using the latest app version after deployment? Interesting. So I'm presuming that question means if it's like an executable or a CLI tool or something like that, does it matter if they're using the latest version? You can't always force a user to upgrade. Like, who, well, as a Windows user, are you really frustrated when Windows is like, I'm just going to install updates and then I'm just going to reboot on your behalf? It's not always a great thing to force your user just to take the latest upgrade. Sometimes it doesn't work within their company. On Terraform, we're version 0.7.11, and we still have people using 0.6.16 because we implemented a major change between 0.6 and 0.7 that meant some user didn't want to upgrade. It changed how software worked. So it's all about supporting the old users, but it's important for us to understand we still have users using that because we have the metrics that tells us what users are using what versions. Any other questions?
Do you have any tips for releasing
Do we have any tips for releasing on-prem? Wow. Like physical servers?
Yeah, it's customer's data center.
Oh, into the customer's data center? That's the conversation that we should have over a beer.
Are you trying to avoid the D word just now?
I'm not. I would. Yeah, I'm not. I'm not going there. I'm really not going there. What he means is the Docker word or containers. I know a lot of people who ship containers everywhere. If it works for you. Any other questions? We'll skip that one like really fast. Excuse me? We'll go straight there and have a beer. It's fine. Any others? Awesome. I really hope that this is like a rant, as I say. Okay, this is not something that you can tangentially take and just implement in your company. But what I really hope that you were able to get from the talk is that it's important to understand how your software runs. It's important to understand that different people within the company come together in order to deliver the systems. If you don't have that understanding, you're probably not going to create the best software you can. Thank you. Enjoy the rest of the conference. I know it's the last day. Thank you all very much.